Welcome everyone to my talk about OpenHPC. My name is Adrian Reber. I'm part of Red Hat's kernel team, and I'm involved in OpenHPC from Red Hat because I used to run HPC systems before I joined Red Hat. So I had a chance to be involved again in my old area where I worked, and so I said, yes, I'm interested to be a part of OpenHPC when we joined in 2016. The last time OpenHPC was here at FOSDEM was in 2016, so I thought this year might be a good point to tell once more what OpenHPC is and what has happened in the last 3 years. And yeah, that's what I want to do here, give an update and see what has happened since. So the microphone is not working?
The microphone is only for the recording.
I have to speak up? Okay, sorry. Okay, I wasn't aware. So it's about OpenHPC. Okay, so my clicker doesn't work. It does work. So my agenda is, I first want to give a high-level view what OpenHPC is. This is basically what I saw first when I looked at the project in 2016. What was my first impression of the project? What does it provide? Then in the next step, I want to tell why the OpenHPC project was created, formed, why it exists. And after that, I want to talk about what is OpenHPC in form of the project management, how the project is set up, who is involved in it, and some details about its usage. And then I want to talk about, again, what is OpenHPC, and in detail, what does the project actually deliver for the users, what can the users use from the project. And the last point I want to mention is what will happen in the next time of OpenHPC and things we are currently discussing. So, what is OpenHPC? When I first looked at OpenHPC, I saw it's a software repository. You can download RPMs, and it provides, you can download it through YUM and zippers. So this already kind of means it's for CentOS 7 and /12. Those are the two platforms OpenHPC currently supports. And it supports the architectures x86 64 and ARM 64. And this is sort of the first thing what you see when you look at OpenHPC, what it does. And now I want to talk about why OpenHPC. This basically depends how HPC systems are usually set up. So HPC systems have a bit of different software requirements, what the users expect to be there, and what is usually available on HPC systems for the users. So one thing you usually see on HPC systems, it has multiple compilers, and this is from different vendors, other compilers, and then they are in different versions. So you have multiple compilers from the same vendor in different versions. So because every user needs a special version, and so you try to provide those compilers for your HPC system. The same goes for MPIs. And you have different implementations of the standard, and there are different versions, and different people need different versions, different implementations. And this goes on and on up the software stack for libraries. You need them all in multiple versions and so on. And one small example I want to make here is if you have 3 compilers and each in 2 versions, you already have like 6 permutations of compilers you want to install. And if you multiply this by 3 MPIs, 2 versions each, you already try to provide like 36 permutations of MPIs with the different compilers. And this is a point where most HPC sites are using some kind of automation because you cannot handle this without automation. And so this is a common setup for many HPC sites. So everyone is doing it in some way. And this is one of the reasons why the OpenHPC project was created. And its overall goal is to reduce duplication of work through a community effort, so that everyone tries to come together and offer ideas, and in case of OpenHPC, even software packages you can easily install to get an initial system running. So the project has a vision and a mission statement. This is the vision statement. It sounds pretty visionary, and I think one of the goals is to make everything better and easier, and focusing on setting up and running an HPC system. And the mission statement is a bit more clear for me. It's more concrete. So they want to provide a software repository. It's what I saw at the first glance when I looked at a project. And it wants to provide best practices, so people who know how to run HPC systems will write down how you could do it if you set it up for the first time, or if you want to change something. So this is the list of the current project members. It's a combination of industry partners, universities, some of the big labs in the US who are all involved in the project, and they are trying to work on the things described in the mission and vision statement before. It's a Linux Foundation project, so I guess it's set up like many Linux Foundation projects. We have a governing board where there's going on discussions, and then the main technical discussions are going on in the technical steering committee. It meets once a week. It's open, so if you're interested what OpenHPC does, or if you want to get involved somehow, you can join this weekly call. It's documented on the website. And another thing is, if you, as an institution, as a university, want to join the project, it's free for academic partners. So if you're interested in the OpenHPC project, we welcome any further input, help, whatever you want to contribute to the project. So this is the list of the current TSC member. It's a long list, so from every member, not every member, but from a lot of members, someone is part of the TSC. There are different roles. We have maintainers and people looking for the test cases. The people on the TSC are voted by the members and are part of the TSC for 1 year. The elections are each June, and currently we always have a project leader. It's Karl Schulz from the University of Texas. One thing the OpenHPC project tries to do, it doesn't try to force anything on you. So it's a big pile of things it tries to offer you, and you can pick and choose and build exactly what you want. So you're not forced to use anything we kind of provide. So there are always different alternatives you can choose. You can rebuild it for your needs. You can use the binary RPMs we provide. So it provides you a lot of tools which can help you in either way you need it. This is a bit about the project history. The first discussion about an HPC community project happened in 2015 in June at International Supercomputing. And the first release was then at Supercomputing 2015 in November. And then since then we do continuously have a release, probably every quarter. So we update the software and do a new release. And the latest release, what was released in November, is 1.3.6, and currently we are working on the next, which is 1.3.7. And now I have a few diagrams about its usage. So this is the number of components over the time. So you see it's not a really big number, but it has some components. It's slowly growing, so we're adding new things slowly to the project, which people are asking for, which people are submitting to the project and trying to get included. The next diagram is about how many components change between the releases, so basically which packages are updated. So the small changes are always only really minor releases, but on the normal releases we get like 30% package updates. And then we have another diagram about our users. So you see also the number of users grows slowly over the years. And this is what people are downloading from us. You see in the beginning they downloaded 1.0 and then they switched so they usually switch pretty soon to the new release. Some people are staying on the older releases. And the only thing we're not sure yet what's happening here is in the last month, a lot of people started to access 1.2. We're not sure what's happening there, but maybe it stops next month again, or we have to find out why people are still interested in 1.2. Another thing about visitors of the build server. So the other thing was okay. So yeah, it's diagrams. I guess not so important. This is about what people are downloading, and now some details about what OpenHPC actually is. So I already mentioned it's a software repository, and it provides RPMs, and the base of all our things is LMOD. It's a environment modules-based implementation in Lua. And the reason why we're using LMOD is that the Texas Advanced Computing Center, TAC, is part of OpenHPC, and they develop LMOD, and so we have a very close connection with the LMOD developers, which is good for us because we can get things fixed, change, we can test things for them, so it's a close collaboration which works pretty good, I would say. Then above the environment modules level we have different provisioning tools. So the provisioning tools are used to set up your cluster. It installs your compute nodes and boots them, and it's possible to run your nodes stateless and stateful. So Werewolf is part of OpenHPC, and then the other one is XCAD, which is basically providing same thing. So this is a point where you already can choose which tool you want to use to set up your cluster. Then we have monitoring tools like there's Nagios and Ganglia. We have different resource managers which are distributing the jobs on your cluster. There's PBS Pro is part of OpenHPC, and then we have also Slurm, which is part of OpenHPC. This is again a point where you can choose if you want to have this resource manager or the other one. And then on top of it there are of course compilers, GCC. Then we have LLVM. Another thing which OpenHPC does, it does not provide the intercompiler, but if you have an intercompiler installed in your system, it will detect this, and it provides all libraries and softwares which can make use of the optimizations already compiled for the intercompiler. And the same will happen at some point with the ARM HPC compiler, so it's working in a similar way, hopefully soon. And then we have MPIs, OpenMPI, MVARPitch, MPitch, more MPIs. Then as our software stack is not really big, we provide spec for further software installation and easy build. So you get a basic installation of a system with compilers and a few libraries, but if you need to install more packages, you can use easy build or spec to install software on top of your HPC system. Then we have container runtimes, Charlie Cloud, Singularity. There are file system clients like Lustre and BGFS and additional libraries. But it's not just a software repository. OpenHPC also includes, in my point of view, excellent documentation and what we call recipes. So we have documentation, how to set up a cluster for each of the combinations we have. So provisioners, resource manager, OS, and CPU architecture. For each of those combinations, we have a documentation, how to set up the system. And the recipe is basically we're pulling out the commands you should type to set up your system in the recipe, so you can just run the recipe and have hopefully a running system. There are also goals to port the recipes, or at the same time as the recipes, support something like Ansible playbooks to install the system and not just long shell scripts. And I think there's later a talk about Ansible in combination with OpenHPC even here at FOSDEM later in this room. And the thing with these documentations, they are each completely tested with each release. So we have a test system where we do bare metal install of clusters using InfiniBand and Ethernet only based clusters on ARM and on Intel CPUs, on SLAS and on CentOS. And we test all the software we provide and all the installation steps for each release. So we make sure that what the documentation we provide actually works. And once you have this all installed and running, you get a user interface using environment modules. And it basically looks the same independent of the operating system, independent of the architecture. So the users don't have to change any paths or name of modules. OpenHPC systems will always come with the same paths and environment module names. So I have like 3 minutes. Okay, so just a bit about upcoming changes in OpenHPC. The next release will be 1.3.7. It will be released in the next 3 months, so probably in 3 months rather than tomorrow. It will include the usual updates of packages which have been released upstream, and we will try to include them. The goal is to include a rebuild of our repository using the ARM HPC compiler. And last week, 2 weeks ago, we started discussions about supporting new operating system releases. There's SLAS 15 exists, and we have requests to enable it. There was the RHEL 8 beta released, and we're discussing how we should handle this. Because from our release numbering, this would mean we will switch to a 1.4 release, because 1.3 means you can upgrade it all the time, and you cannot really probably upgrade from 1.3 to 1.4. But doing this would mean that we probably have to drop the support for CentOS 7 and SLAS 12, because right now the community does not think we can support 4 operating system releases, and the main problem is the testing. So we build all our packages from a single source. So the building is not really the problem, but to make sure the result which we provide actually works would require the testing, and this is something we are currently discussing how to handle this correctly. And when should OpenHPC switch to SLAS 15 and RHEL 8? Because people in the beginning are always not so interested in trying new operating systems on their HPC system. So we have to find the right point in time. How do we deal with the old releases? How do we deal with the new releases? And I have a short overview here about links to the project, our homepage, our CI system, our GitHub page with all the spec files for the packages. You can look at our CI infrastructure, how the current state of our packages are and how the testing goes. And now I'm already in the end, and thanks for being here, thanks for listening, and are there any questions? The question was, what is the best way to start helping us? So if you have a problem already, fix it and submit it. Submit a pull request. We will. I'm pretty sure we will include it. If you think there's some package missing, we have a submission process. I think I listed. It's somewhere here. Component submission. So if you think there's something missing, you can submit the component submission, and this is, will be included with every release. So this every 3 months we can include new things. You can, I don't know, have a look at the repository. Basically, if something's broken, you fix it, we will include it. So, sorry, I'm not sure what this question is about. Sorry. Okay, so if there's integration testing between the components, was it that? Yes. So we do install testing, and we have, I would say for most of the libraries, we have a test code which we run. But again, it's test code, so we make sure that the provided library interfaces are working, and the test code runs, and that it can do MPI communication using the nodes in our test cluster. So there is a certain kind of, we kind of try to make sure that it works, but it's not a complicated computation which we run on our test system. So we make sure that the applications and the libraries are working, but I don't know at what point you can say they are 100% really tested. So.